Alright, so problem 3 of homework 8 is calculate the wavelength of light. That's the third minimum at an angle of 30 degrees and falling on double slit separated by 3 microns. So, third minimum. So, now we're talking about d sine theta, right, equals m plus 1/2 times lambda. Now here's where with the minima is where things are a little goofy. All right, and they're a little goofy because for the maxima, the world is symmetric. There's a 0, there's a 1, there's a 2, there's a 3, there's a 4. There's a -1, a -2, -3, -4, yada yada yada. Maxima are easy. Minima. Here is m equals 0 minima. All right. And so what would you call the third minima? This is 0, 1, 2. So m equals 2 is actually the third minima, because in the other direction, and in the other direction, right, even more confusing, -1, -2, -3. -3 is the third minima in the other direction. So minima get a little confusing. You have to think about the geometry and what's going on, but we're going to go with where we are here. We're going to just say, all right, so third minima, that means m equals 2. All right, we have m equals 2. We have d equals 3 times 10 to the -6 meters, and we have theta equals 30 degrees. The only thing we don't have is lambda, right? So we're looking for lambda, which is going to be equal to d sine theta divided by m plus 1/2, right? And so this is 3 times 10 to the minus 6 to the -6 meters times sine of 30 degrees. All right, all divided by we've got m equals 2, so 2.5, right? All right, let's pop over to Excel, figure out what we got here. So we've got 3e to the -6. We've got the sine of radians of 30, because remember, Excel uses radians. So we've got to convert the 30 degrees to radians to get the sine. Got 2.5, so the wavelength is 3 times 10 to the -6 times the 0.5 divided by the 2.5 is 6 times 10 to the -7. All right, so the wavelength is 600 nanometers. 600 nanometers. And that's it for problem 3. And there you go.